Good evening, everyone. Thank you for coming this evening. My name is Kathleen Britton. I'm on the board of Storm Surge, and I'm delighted that you're all here this evening. Normally I have some slides for you, but we were having some technical difficulties, so we'll just make sure that Wayne's slides will work for us. For those of you who are new to Storm Surge, we were founded in 2013 as a threat to our coastline from sea level rise was starting to become a recurring problem to our community. So to address the coastal issues of climate change, we promote science-based outreach and education. We also create original content in video format for use by schools. And you can always learn more about us by looking up our website. We are this evening extending our gratitude to the Institution for Savings, which is sponsoring our speaker series this year. We're also thanking the City of Newburyport for the use of this beautiful space in the community center, and to the Greater Newburyport Community Media Hub. They are filming this. It is going live right now, but it will also get posted on our website in a few days. We exist because of people like you who share our mission to empower our community with knowledge that's needed to actively mitigate and adapt to our rapidly changing shorelines, coastal and marsh environments, and other local weather patterns. So thank you very much for your support and for your activism. So before I introduce our speaker this evening, I want you to please make note that our next speaker series is on Thursday, November 20th. Kurt Rogers and Jose Tapia of the Merrimack River Watershed Council are going to address the health of the Merrimack River, focusing on water quality, combined sewer overflows, and restoration. And when you go to our website, you can register for that now as well. But for this evening, we are delighted to once again welcome Wayne Castonguay, who previously presented at Storm Surge in 2021. We were just talking about that a moment ago. He was discussing the relationship between excessive water use and its relationship to drought. Did I have that correct? Okay. Frequently referred to as a lifelong protector of the Ipswich River, Wayne started volunteering as an Ipswich River Watershed Association volunteer in high school, and after college, he worked for a variety of organizations, including his first job with the Mass Division of Maine Fisheries. Followed that by some time with the Trustees of Reservation, and he eventually became executive director with the IRWA for over 13 years. He was lured back to the Division of Marine Fisheries in 2024 with an opportunity, as he put it, to make a difference by hopefully engaging the shellfish community and to be a resource to help make the industry resilient in light of climate change. So tonight, Wayne will take us on an exploration of the rich history of this iconic fishery. He's going to examine how climate change is reshaping coastal industries, and he'll present some potential pathways to preserve this vital resource for future generations. So it is my delight to welcome you. Thank you.
Thanks, Kathleen. That was a great introduction. I learned something. So it's great to be back here at Storm Surge. As Kathleen said, I've been here before, and particularly in the early years, and I was delighted to get the invitation. And of course, I was happy to say yes. And then seeing so many familiar faces in the audience, it's great to be here. So as Kathleen said, we're going to talk about our favorite river here. At least up here, it's the Merrimack. Down my way, it's the Ipswich, but we love all our rivers. And a more recent happening here in the Merrimack with regard to the closure of a real legacy fishery here in the Merrimack, which I'll talk a lot about. I showed this old historic map back from the 1800s of the Merrimack, because we're really talking about a century legacy here that's really coming to a change, and I would like to put a positive spin on it. It's some bad news, but I think a lot of good news here too as well. And then of course our bucket of soft-shell clams here. We're talking mostly about soft-shell clams tonight, as you'll hear. I know Mast Oyster Project's in the back, and we're starting to grow oysters in the Merrimack, but historically it's been primarily a soft-shell clam fishery, fried clams, steamer clams, and as you'll hear, a lot of it started here in the Merrimack. So just real quickly, we're going to talk about the estuary part of the Merrimack. And for our purposes, we're really talking about the 95 bridge east to the ocean. This is really the estuary. Certainly it's tidal upstream of 95, but we really transition rapidly to what's called a tidal freshwater wetland. The Merrimack actually has the largest tidal freshwater wetland in the Northeast. It's our rarest wetland habitat type, so it's really, really special. That's where all the short-nosed sturgeon live and all the anadromous fish live. What we're really talking about here, and in terms of shellfishing, we're talking about the lower estuary, because once you get into the river, downtown Newburyport, water quality just can't support shellfishing, as we'll talk about. So largely we're about the mouth of the river here, but also south and north, up into the marshes of Salisbury, up the Blackwater River, and believe it or not, way down into Plum Island Sound, all the way down to Pine Island Creek in Newbury is actually considered part of the Merrimack estuary, because there's a real divide at Pine Island Creek. South of there, it's Plum Island Sound. North of there is the Merrimack. So this part of the marsh is very important to the fishery as well. And then I'll spend much of tonight talking about a little building we operate right here at North Point on the end of Plum Island. So keep this geographic reference in mind as we move forward. Just really a brief history of the shell fishery in the Merrimack. As I said, it's got a real legacy to it. Obviously before 1620, when the Pilgrims came, it was exclusively used by the Native Americans. As many of you heard, especially you history buffs in the audience, we have old shellmans all over Newburyport and Salisbury attesting to the history of shellfishing to the natives. It was really a critical resource, something that could get them through harsh winters, and they relied incredibly upon it. But from the time the Pilgrims landed to the late 1870s, 250 years, people did not eat clams, believe it or not. People eschewed the clams. They thought they were gross. They just wouldn't eat them at all. But they were still very important for commerce. Two big uses for clams. First of all, for animal feed, particularly hogs. They really is the primary feed for that 250-year legacy that we fed our pigs. And we also let the pigs get their own food and let them out on the clam flats. It was a big industry. But the real big industry was bait for the Gloucester cod fishery. Before we had steam engines and then later diesel engines, all fishing, and what really was the foundation of New England for centuries, even before the Pilgrims landed, was hook and line cod fishing, and you needed bait, and soft shell clams were the #1 bait. And in the Merrimack, there were huge industries, and they used to sell these by the barrel and then salt the clams for the cod fishery, and it was a huge industry for a couple of centuries here. And then in the early 1900s, everything went away. What happened, and it took us to the early 1900s, believe it or not, to figure out the connection between eating contaminated food and human illness. We didn't even know microbes existed before then. And then finally, in 1924, the entire country literally got sick. Back then, oysters were a delicacy for everybody. Everyone really loved oysters, and they were shipped all over the country because of the advent of refrigeration and ice storage. And in every major city across America, thousands of people died because of typhoid. And they finally, for the first time ever, figured out it was because of contaminated oysters. And virtually all of the developed shoreline throughout the entire country was closed to shell fishing until we could figure this out. So immediately, centuries of legacy were closed in one fell swoop in 1924, including the Merrimack as well. In that year, the Surgeon General convened a big convention to figure out what was happening, and they developed what's called the National Shellfish Sanitation Program, NSSP. We'll talk about that a little bit throughout the talk tonight, that acronym. And they really wanted to basically improve the sanitary control of shellfish. And basically what was happening is disease would follow what's called the fecal-oral route. Disease-causing microorganisms, bacteria and viruses, would be deposited through feces into the water, and then the shellfish would pick up those contaminants and pass it on to people and make them very sick. But what's really incredible is this date here. Only 3 years after that, we were able to open softshell clams in the Merrimack, and the Merrimack was the first shell fishery in America to be reopened after it was closed. It was pretty amazing, and I'll talk a little bit more about that. So that's a brief history. I want to go back to why this all is. It really has to do with the anatomy of shellfish. And when I talk about shellfish, I'm referring to, it's a shorthand in our business, to bivalve mollusks. So shrimp, lobsters, crabs, we don't call those shellfish in our business. We're talking about mollusks. 2 shells, and what they are filter feeders. They can't swim like other fish. They're stuck in the bottom. And how they feed is they pump huge amounts of seawater through their bodies and filter out the food and, unfortunately, the microorganisms, the pollution, anything in that water column, they'll concentrate in their bodies up to 100 times the level in the ambient water around it. So you can see right there, it's the biology of these critters, why people are so susceptible to illness. And how it works basically is they have 2 siphons. One's called an inhalant siphon. They pump the water into their body. This blue part is the stomach, and they basically filter everything out of the water, and it sits there for that to digest. And then all the waste, what's happening here? And then the waste goes back out the exhalant siphon. And so these things can be dangerous in contaminated waters. So that's really what we're talking about. And so the NSSP, this manual is first developed back in the early parts of the 1900s, and it's updated every 2 years, and it controls the sanitary quality of the shellfishing industry. And there are 3 pieces of that. One, which I'm going to talk about exclusively tonight, it's the classification of what we call shellfish growing waters. The second part is about commerce, the safe processing and sale and distribution of shellfish. And then third piece of it is enforcement, how we can enforce these rules. So I'm only going to talk about the first part of that. So in the NSSP, the whole program is based on ensuring that shellfish are only grown and harvested from safe, clean water. We don't test the shellfish themselves. Shellfish are animals, and just like you or I, every animal is unique. And so testing a few animals won't necessarily give you the data you need. We instead test their environment and make sure they're living in clean waters. And there are 5 classifications in the NSSP for shellfish growing areas. And I'll just go through them briefly because they're very relevant to the rest of the talk. One is approved, shown here in green. That means the water is safe for the direct harvest and consumption of shellfish. You can harvest them yourself, take them home and eat them with no restrictions whatsoever. Conditionally approved means a clean area some of the time, and there's a condition on it. For example, after a heavy rainstorm or some other predictable event that we can determine that you can predict, you can put a condition in our approved area. This third classification, this middle one, this gold one, restricted, is really what we're going to talk about the rest of the night. Restricted means you can harvest them some of the time, and that means there's a moderate level of contamination in the water, but you can reduce that contamination, which I'll talk about a little bit. And then, of course, conditionally restricted, it's the same. You can predict when it's going to be moderately contaminated. And then prohibited, you can't use shellfish for any reason in a prohibited area. They're just too dangerous to eat for human consumption. And you can see this is a map of all of our growing areas in Massachusetts. We have 300 of them. The Merrimack is one of 300 classified growing areas. And you can see in the middle and northern part of the state, it's mostly prohibited. That's where all the people live. That's where the sewage is. And then down as we go towards Rhode Island, it improves, a lot of green, less populated, but just as importantly, it's all sand and gravel there, so pollutants on the ground are filtered before they enter the water. So that's why the difference across the state.
The top of that map is Newburyport?
Yep, right here is the Merrimack, and we have red and gold in the Merrimack.
How long has that been red?
Since 1925. But we'll talk a little bit more of that because it's a part of that is actually gold here, conditionally restricted, because we are clamming in the Merrimack today. So the only reason we can clam in the Merrimack River is this incredible building out on Plum Island called the Newburyport Depuration Plant. It was first built by the city literally 1 year after the nationwide closure. If you can believe that. The city was incredibly progressive. Back then there was a huge clamming industry in the city, and immediately after these flats were closed, after the big typhoid scare, the city, within a year, decided to do something about it, which is amazing. And they built this plant out on North Point on Plum Island. This is a picture of the plant in 1930s. It was a black and white photo, and now it's been colorized, and you can see the Model Ts there. And this was the actual pump. They used to take Merrimack River water, and you could see the rest of the island's pristine, no development. They just stuck it out in the dunes. It was incredibly progressive for the city to do this. It's the oldest continuously operating depuration plant in the country, the world. It's the largest plant in the country. It's the only publicly operated depuration plant. Everyone else is private, owned by industry. And over the last century that it's been operational, fully 1/3 of all the steamer and fry clams in the entire state of Massachusetts has gone through your plant. It's pretty remarkable.
Still operational?
We'll get to that. Hold that question. So I've used this term a little bit, depuration. What the heck does that mean? It's a technical term. It simply means purification naturally. So essentially, you're allowed to put shellfish in a controlled environment and allow them to naturally cleanse themselves over time in pure, clean seawater. So it's just a technical term for filtering, natural cleansing. And once you come out of depuration, those clams are safe to eat. So a little bit more about our depuration plant here. I think most of you have been out to North Point. Here's an aerial view. This is the Newburyport City parking lot and the town beach over here. We all love captain's fishing parties over here, the big boats. And so our depuration plant is right here next to captain's fishing charters. And make note of this little blue dot up here in the dune. I'll come back to that a little bit. So again, the 1930s. Then in the 1960s, the city got tired of the plant, and they gave it to us. So we've been operating it ever since the 1960s. And just before they gave it to us, they did a big renovation. And so this is looking from the beach side at the plant. From the back, and you can kind of see this old Jeep there. And then this is what the plant looks like today from the parking lot. And if you went out there today, it would look just like this. So it's been in operation for almost a century, cleaning Merrimack clams. This is just an inside view. This is kind of a floor plan. There's a series of deep tanks, each of which can hold 100 bushels of clams, so they're quite large. There's a huge laboratory because you have to test the entire process. Clams coming in every single day until they can be documented to be safe to eat. Then they can be discharged. And these are the tanks here. And each tank is intimately connected to pumps. And on the back wall here are ultraviolet treatment systems, and that water is circulated as the clams purge themselves. Those contaminants are zapped by ultraviolet rays, and so this water is sterilized, and over time, the clams just get cleaner and cleaner through the natural cleansing process. And you can see the bushels of clams here. Each one of these baskets is a bushel. And here's an operator, obviously, hundreds of bushels at a time. We use a crane to move them in and out. Typically, the clams stay here for 2 to 3 days, is about how long it takes them to purge themselves. The real focus of this rest of this story in terms of climate change, and I will get to climate change, is all about the source of water for this treatment plant. You can imagine it's all about clean water. And we source our water, obviously not from the Merrimack, it's too dirty, is through a well. And if you remember, I asked you to focus on this blue dot here. Our wells are way out in the dune here. And it's a remarkable geologic feature to have a saltwater well. It's almost unheard of because you need the right geology. And so we're incredibly fortunate. That's why we put the plant, or the city put the plant on the island in the first place. Because what's very unique is there's a saltwater aquifer under the island where we can draw pure, sterile seawater, and most importantly, it's uniform year-round in terms of temperature and salinity. So it's very stable. It's 52 degrees every minute of the year, and the seawater is 32 parts per thousand. So it's pure seawater. It's really, really special. And for those of you who lived on the island used to, you notice under the island is also a freshwater aquifer where, believe it or not, up till 20 years ago, every house on the island had a well, if you can believe that. But the siting is really critical because I think this animation might work. So where the plant is on the left here, if you dug a well, you're not going to hit the salt water. So you have to be right on the edge of the beach to intercept that saltwater wedge underneath the fresh water. And the reason that works is salt water is heavier than fresh water. So the fresh water floats on top of the salt water. So that location of the well is critical. It's rare, it's unique, but it's also incredibly vulnerable, as we'll see. So just real quickly before we pivot to climate change, these areas in gold are the restricted areas or the depuration areas that previously served the plant until a couple of years ago. So here in the Merrimack, these gold areas are open to restricted shellfishing. And as you can see, it's mostly in the outer estuary. In the middle here, we can't harvest because that's where the Newburyport wastewater plant discharges, so we need a big buffer zone around that plant. And then, of course, upstream, we have Salisbury, Amesbury, Merrimack, Lawrence, Lowell, Haverhill. And so rivers, by definition, tend to be too dirty to shellfish. We really need the highest water quality to support shellfishing, much more clean than for swimming even. So it's tough to have clean enough water for shellfishing. And the other big areas are much more south of here. In Boston Harbor, all these gold areas come to the Newburyport plant. And then up here in the Pines and Saugus River and Saugus and Revere. So those are where most of the moderately contaminated clams in Massachusetts come from that utilize the Plum Island plant. Historically, there have been areas in Danvers, Beverly, Salem, as well as the Ipswich River formerly come to the plant. But in the recent past, these areas come to the plant. And then these circled areas in outer Boston Harbor are actually cleaning up. So they're going to be coming off the table in terms of depuration, and those clams very soon can go straight to market. So unfortunately, a couple of years ago, in November 23rd in 2023, we had a big coastal storm. Many of you might remember it, which actually took out our seawater system. And these are a series of photos that show you that change. On the left here, this is our well, and this was before the storm, a week before the storm. You could see the ocean's getting perilously close to our wellhead there. And then a week later, it was inundated by that storm. And then within a month of that happening, North Point just disappeared almost entirely. And we have 2 wells there. And this, can you see this one way out in the water? Yeah. This is actually this well here. So within a month, we lost 100 yards of beach. And even our second well, which was thought to be totally invulnerable, got inundated. And you can see these are the electrical conduits for the pump. Electricity and seawater doesn't mix well. So we had to close the plant on November 24th that year, and it's been closed ever since. Also, that same storm took out the primary dune, which formerly protected all of North Point. And for those of you who may not recognize that term, the primary dune is the first big dune above the beach. And typically the primary dune stops all storm surge and all coastal inundation. However, that dune is where the wells were, and that dune was washed out. So the ocean had a free access to North Point and the Newburyport parking lot and our plant. And then for the first time ever, it flooded that January. The whole building was knee-deep in water, and not only did we lose our seawater system, we're losing the building itself. And as soon as we could get out there in March, we actually had to get out on the beach, and this is low tide, and this is all underwater at high tide. The Coast Guard actually said these are hazards. The well casings were 10 feet above the sand, and really a hazard to navigation. So we went out there under emergency order from the Newburyport Conservation Commission and had to clean up all those old wells. So the plant's shut down. There's no shellfishing. The industry is essentially closed. So what do we do? These maps really show you what's going on, and I know the Plum Island erosion has been in the news for years and years and decades, and much of the area has been away from North Point, but it finally reached us here in North Point. And you can see in 2014, here are our wells, almost 400 feet from the ocean. And then in 19, you can see we lost a couple hundred feet of dune and beach here. And then by 2023, it stayed roughly the same, but our outermost well was right on the edge there, but still on dry land and operational. And then the next month is when that storm really took it all off. And this red line, which is superimposed on every shot, is the actual shoreline after that storm in February. And that's roughly where the shoreline has stabilized today. So you can see our wells are well in the ocean today. So a real problem. So what did we do? We hired a firm to do a study, and GZA, many of you in the local area know GZA is the primary engineering firm working on restoring Salisbury Beach, the Newbury Beach, and Plum Island. So we really had the local experts. We asked them to do 2 things. One, estimate if it's feasible to open the plant and fix it, restore the seawater system, and how much it would cost. And then secondly, to, provide a vulnerability analysis to us for sea level rise and storm surge. And so basically this is what they come up with. We also did a complete alternatives analysis. And then of course we engaged the cities, the community, and most importantly, the shell fishermen who were dependent on this facility. So we were faced with all of this data, and we had to make a decision. So this table shows what GZA came up with, about $700,000 to reestablish operations of the plant. They did find a new spot for the wells, so that was good news, right next to the Newburyport parking lot. So they found good salt water there, so that was great news. And then we also had to flood-proof the plant as well. So that came up to about $700,000. It's very complex ownership out there. There's a bunch of landowners. Our wells were across 3 other landowners' properties. Back in the old day, you could do things like that with a handshake. Nowadays, that's a lot more difficult. So how do we get the water to the plant became a big challenge for us. But GZA really concluded 2 pretty eye-opening things for us. One is the plant's going to get flooded every year. So how do we deal with that? And then secondly, they said within 25 years, we're going to have to retreat from that location altogether. In 25 years, the site is going to be gone, is what their study concluded. And then obviously, what this means for the fishers and the industry itself. So we had a tough nut to crack. So I'm going to dive into a little of these things a little deeper to give you a feel for our decision-making process. So this was an analysis in the GZA report. We're fortunate here in Massachusetts is that we have the most accurate and technically complete storm surge and sea level rise modeling in America. And it's called the MCFRM model for you climate change geeks in the audience. And not only does it take into account sea level rise, but it's really sophisticated about modeling storm surge as well. So it really combines those two things. And these colors show the inundation model results. The blues and purples are the deepest water. And you can see right where the plant is. And I think most of us have probably been out there. We're in an actual valley out at North Point where the parking lot is. There's a real low spot. And you can see in 25 years, it's going to be under 10 feet of water regularly during storms. So you can see we're really vulnerable. However, what this model doesn't depict, it also shows that the primary dune is still intact. And of course, we know the dune is gone now. So even at regular king tides without any surge, the ocean can flood right into this basin. And we've seen that repeatedly since the plant flooded. It's flooded at least twice a year since 23. And that's because the primary dune is gone. The king tides in November, go to that parking lot, it'll be a lake, I guarantee it. So what do we do with this information? Moreover, we looked at the fishery and the trends in the fishery. And you can see statewide harvests of softshell clams in the left. It's been a downward trend all over the state. But look at the clam, what we call throughput at the clam plant. Back around 2000, we had about 53,000 bushels of clams coming through that plant. A huge number, 1/3 of the whole harvest in Massachusetts. And then the year the plant closed in 23, less than 2,000 bushels. So this fishery is plummeting. And the reason for that are myriad. One is our waters across the state are getting cleaner. So every year we're reopening these formerly contaminated areas to straight harvest. Coupled with the decline in the fishery, also a lot of the fishers are getting older and aging out. Young folks don't want to get into this backbreaking work. So the result is our clam plant, as we call it fondly, isn't seeing many clams. And then this is the actual participation in the industry. Because these clams are contaminated, we have to have specially licensed expert clammers going there. We have what's called a master digger who basically oversees the operation, and then we also permit what's called subordinate diggers, and they have to sell their clams to an individual master digger who's then responsible for transporting those contaminated clams through the entire process. And you can see the numbers of diggers are just plummeting. It's 82% in the last 25 years, so there's not many diggers left. We did look at all kinds of options to maintain the fishery. One is obviously, which I just talked about, is restoring the plant, fixing it. We also looked at moving depuration to another facility in the state. We own a couple of other buildings across the state. Some dealers and industry have buildings on the waterfront. We looked at all kinds of options to move this in a less vulnerable location. We offered to give it to private industry and let them deal with the issue. You're also allowed to move clams into clean waters, so that's something else we looked at to salvage the Merrimack fishery. We did come up with some funding to at least give the clammers some income during the time we were making this decision. And then, thankfully for us, There's another depuration plant relatively nearby in Elliott, Maine, which I'll talk about in a minute. So we looked at all these evaluations, and basically we came to the conclusion, and I'm sure it's no surprise, that it just didn't make sense to keep our clam plant open. The cost benefit wasn't there. It's too risky. Climate change is likely going to eat it up within 25 years. We were actually spending way more money to operate it than it was contributing to the economy, so that didn't make sense. We were down to about 20 people fishing for this industry as well, and we basically concluded, and the governor decided in February of this year to cease operations at the plant permanently, which was pretty devastating to this legacy, also to the 20 fishers who depended on this fishery for their livelihoods, or this facility. It was a really tough challenge. And this just gives you an idea. You know, there's been campaigns on and off over the years to save the clam plant. A lot of people rallied not only for the economic benefit, but again, the 100-year legacy of this incredibly unique facility. It was really unique in that Boston Harbor, one of the most polluted estuaries in the country at the time, we could actually harvest clams there, and especially around Logan Airport, some of those productive clam flats in the whole world, they came to our plant here in Newburyport. And then some really legacy seafood companies who really depended on this for their livelihood. So it was a really tough human story for us to make that decision. However, we're incredibly fortunate is 25 miles up the road, there's a privately run depuration plant called Spinney Creek, right over the border of Portsmouth, right over the main bridge, exit 1, right here in Spinney Creek. There are only 4 of these in the whole country. Ours was one of the 4 which we closed, so we're down to 3 in America, and we're lucky that one of those 3 is 25 miles up on the road. So what we've done is we've offered to subsidize the cost differential of going up to Elliott, Maine, and we were able to keep the Merrimack River fishery opening, and they actually only closed for a few months. And I'm happy to report today we're digging, just like we did always in the Merrimack, and they just have to take a little truck ride up the street. So we're really lucky there to keep the Merrimack fishery open. Unfortunately, the Boston Harbor fishery, they've just felt it was too far for them, and so they've not come back. And if you remember that slide of Boston Harbor I showed up, those red circles, all those areas now are being reclassified to approved so they can go directly to market because the Boston Harbor cleanup has been so successful. If you can imagine, Boston Harbor has some of the cleanest water in the whole state today. It's really remarkable. I want to wind down really talking about climate vulnerability. Although it's a good news story for the Merrimack River fishery, we are quite concerned about the future of soft-shell clams in general. They have been determined to be the least resilient shellfish species in America. They are highly threatened by climate change. NOAA and the National Marine Fisheries Service has inventoried all commercial species of fish in the country and analyzed them for their vulnerability to climate change. And they had this pretty slick system, color-coded system here. And unfortunately, soft-shell clams have been deemed very high vulnerability to climate change, the highest ranking of any species. And so, unfortunately, we do expect the population to continue to decline over time. Right now, the Merrimack is doing pretty well, but the future is highly questionable. These are very sensitive species. They're soft-shell clams for a reason. They have thin shells, and as ocean acidification increases, these are probably the first mollusks to stop being able to lay down shell. Also, they're really sensitive to temperature. They don't like hot water. They don't like warm water. Our water's warming. So unfortunately, the future is pretty concerning for this species. But for now, the fishery's open. Eat your fried clams, eat your steamers. They're great and healthy. And we'll probably harvest about $1 million worth of clams out of the Merrimack this year. So it's still pretty robust. Every time it rains, it closes for a few days. We have a rain closure right now. But about half of the time, if you look real hard in Salisbury or Newburyport, you'll see a group of about 15, 20 folks out there digging your clams. So we can still enjoy them for now. So that is it. If folks have any questions, I need to stay near the mic for those listening at home, I've been told. And I'm going to have to repeat the questions after you ask them for the audio. So just heads up. Back.
It seems like if there's areas that are clean enough to have the clams grown, transporting clams from contaminated areas to those areas for the time necessary for them to purify would seem like a really logical thing. I mean, you realize there's transport costs and all that. But you don't have to have a plant, you don't have to have a maintenance. I mean, is that only a small option, or is it not an option? You mentioned that.
So the question is, can you just transplant contaminated clams to clean areas and allow them to naturally depurate in the new areas? The answer is yes, and that's how most of it is done across the country. It's called transplanting. However, that doesn't work for soft-shell clams. And soft-shell clams are very fragile, again, their name, and unlike a lot of other shellfish species, once they're over an inch, they really can't dig themselves back into the mud or the bottom. And so they really can't be transplanted like the other species can. So quahogs, oysters, things with hard shells, razor clams that have big active feet and they can dig themselves in the sediment, those things can be transplanted, but it's not really feasible for soft-shell clams.
Shellfish purification plant on the Cape?
The question is there a shellfish purification plant in the Cape? And the answer is no. There's 3 left in the country, as I mentioned. One right here in Elliott, Maine, one in New Jersey. There's a sister plant. They're near each other, but we count them as one. And the other one is in California for oysters. Reg?
How about as the water's warm, the quahogs are less sensitive to water temperatures than soft shells. So have you thought about maybe energizing the quahog fisheries in this water? And as the water's warm, it's going to benefit the quahogs, right?
Yeah, so the question is, can we replace soft-shell clams with quahogs? So quahogs, which is a name used for several types of clams based on size, little necks, cherry stones, what we call in the industry hard clams as opposed to soft clams. They like warmer water. They're very prevalent from Cape Cod to Florida. They're more of a southern species. So as our water warms, can we benefit from quahogs here on the North Shore? And the answer is most definitely yes. For those of you who are out on the clam flats, you might see them now. They're starting to show up on the North Shore more and more. If you go into Salem Sound and the Danvers River, there's lots of them. Plum Island Sound, they're starting to harvest quahogs, and we are seeing a few here and there in the Merrimack as well. They don't do as well in fresh water like the soft clams, but certainly quahogs are coming. Yes.
What are the contaminants that are in the water? Is it like bacteria, or is it a biological origin, or is it chemical?
The question is what type of contaminants are in the water affecting these shellfish, and the answer is all of the above. We are most concerned with bacteria and viruses that can cause acute direct human illnesses like typhoid, norovirus, and all kinds of bacterial illnesses, food poisoning type illnesses, because it's instantaneous and it can make you sick or even kill you in certain circumstances. So that's what the program is mostly about. But you also have to take into account two other types of contaminants. One is what's called naturally occurring biotoxins. These are chemicals produced by algae, and I'm sure you've heard of red tide. That's a class of biotoxins, but there are several types. So these are naturally occurring pathogens that these shellfish will ingest, but also chemical contaminants. I mentioned earlier, in the middle of the Merrimack, there's a big closed zone because of the Newburyport wastewater plant. So anything around a discharge from a wastewater plant has to be closed at all times because there's hundreds of potential toxins in wastewater that we can't possibly test for that accumulate over time in our bodies. They might not make you sick that day, but over several months or a year, they can make you sick. It's basically a chronic illness, so those illnesses we have to take into account as well.
There may not be an answer to this question, but what's going to happen to the deep aeration building out in Plum Island?
The question is, what are we doing with the clam plant now that it's closed? It's owned by the state, and we have to go through what's called a deaccessioning process with a state agency that deals with that. So right now, we're just beginning that process because, again, the decision was made to close the plant just in February. And so we're working with that state agency called DCAM right now through that decommissioning process. And what happens is there's usually a hierarchy. So it's offered first to another state agency, then the federal government, then the municipality. The city of Newburyport has toured the facility and thinking about it for a lot of potential uses. And then if no other governmental agency is interested, then the nonprofit sector will have an opportunity to get the plant. And then after that, it will go to private sale. So that's the process. We've just embarked on that. And it takes a year or two for that to happen.
Sounds like it's going to be underwater, so how does it have any potential uses?
That's a great question. The question was, well, if the plant's so vulnerable, why would anyone else want it? If you notice what's happening on Plum Island, for those of you who live there or go out there, is we're elevating everything, right? So that seems to be how people are adapting now, is elevating the structures. And so it's conceivable that someone could rebuild the plant, elevate it, and find a future use for it. Or flood-proof it and try to eke out the next 25 years or so. So there's a couple options.
You made some interesting points about the future of the soft-shell clam, and I wonder if you might unpack that a little bit in terms of the decline that you talked about, in terms of that resource. And also, is there a relationship between water quality and improving habitat and maybe extending the life of the plant, increasing the longevity of the plant as a resource? And finally, are you being paid tonight as a federal employee? Because we sure appreciate you being here.
So I think there were three questions there. The first one, I am getting paid, but I'm a state employee, so I don't work for the federal government. And then the other two questions were to talk a little bit more about the impact of climate change on this species, softshell clams, as well as the effect of water quality on the species. Again, as I started to talk about, these are really susceptible to ocean acidification, and as we know, oceans acid levels are increasing, and so softshell clams are thought to be one of the most vulnerable species in that regard. Also, warming water is a big concern. These are cold water species, so warming water makes them super vulnerable as well. However, a large issue as well is shellfish are really particularly affected by diseases, and so there's all kinds of diseases and new diseases and exotic species from across the globe impacting our waters. And so parasites and other competitors are really doing a potential threat to the species as well. In terms of water quality, interestingly, the sewage contamination that we talk so much about in terms of public health is actually a source of fertilizer. So historically, they did pretty well in polluted and contaminated waters because there's lots of food for them to eat. And the fertilizer makes the algae grow, which these are vegetarians, they feed on algae. And so as we clean our waters, there's actually less for them to eat. And so there is definitely a correlation between softshell clam populations in polluted areas versus clean waters. They do just fine in contaminated areas. Yes, sir.
How far south do you find this type of soft shell clam that we have here in New England? How far south do they go?
So the question is, how far south do these go? Softshell clams are native from Virginia to Labrador, and we're right in the middle. That's why we're the world's most productive softshell clams. That's why Massachusetts is the leading harvester and producer of softshell clams in the world. But their range is moving north. So they're no longer in Virginia. They used to be in Chesapeake Bay. They're no longer there. Right now, we start seeing some harvests in New Jersey and Long Island, but south of Cape Cod, they're disappearing fast.
So that indicated that they could be wiped out?
It's thought in the very near future that the species won't exist in southern New England south because of increasing temperature. Yes.
It's hard to, it keeps on getting warmer every summer. The water's warmer out there. And I wonder how far away are we in the Merrimack from it being unsustainable temperature for these soft shell clams in the summertime?
The question is,
so warm, it's just so warm.
the question was how far away are we from losing this species in the Merrimack? I think quite a ways. Again, historically, they've gone down to the Chesapeake, and we're a long way from being as warm as Virginia and Maryland. So we've got quite a ways here. There's a real break in the seawater temperature at Cape Cod. And so we've got a lot of time north of Cape Cod, I think. It'll certainly be many decades before we have to worry about that, I think, here in terms of temperature.
Wayne, the Gulf of Maine is warming faster than almost all the water bodies around North America. Is that taken into account in the modeling of how the water temperatures will rise in our area here?
The question is, Gulf of Maine is warming faster than any other water body in the world. Will that affect softshell clams? And again, I think it's the same response as before. I think we've got we're still in the sweet zone for softshell clams temperature-wise. Even if it rises 5 degrees, we're still pretty good because it's still cooler up here than it is south of Cape Cod, and they'll probably do all right. It's similar to what's going on with the lobsters. Lobsters have disappeared in southern New England, but they're still doing pretty well here, so we probably have quite a bit of time. Eventually, obviously, probably not, but I think we've got a fair bit of time, at least here in the Merrimack.
What's the relative risk of ocean acidification on the timeline for the species health?
Yeah, the question is, how much time do we have in terms of ocean acidification and softshell clams? We're perilously close. We don't know how quickly the ocean acid levels are going to grow. There's lots of buffering capacity out there, but we're very close right now where in the laboratory they are not able to produce shells. So we're right on the edge now for that. But we don't know if we're going to go over that threshold. There's really poor forecasts in terms of ocean acidification increases. It's a little different in terms of predicting than temperature. But it could happen pretty soon. Yes.
A little bit of a different question. There was the data around sea level rise, NOAA 50-year, I think, forecast. Does that change drastically the sand flats for clamming and so on? And is there a risk there?
Oh, that's a great question. We're all worried. The question was, obviously, with sea level rise, is that going to affect the habitat where these critters live? Because they live in the intertidal zone and in the dynamic shoreline. And the answer to that is we don't know, but we think, because they're a relatively short-lived species, that they're pretty adaptable in terms of habitat. So as sea level rise, we think the sea level will move inland. And in fact, that might actually create more flats because there'll be more erosion of coastal bank and more energy out there converting upland into intertidal habitat. So it's possible that the clams will just move with the habitat inland. So there's not a lot of, I would say, concern about losing habitat. It'll just move.
Okay, thank you so much.
Thank you all.
That's good.